because next up we've got Mikko Vatanen from the CSC IT Centre for Sciences, and he's going to talk about the digital preservation workflows that they've been developing there. So, Mikko, if you're ready, it's all yours.
Thank you. Are my slides showing?
It looks like they're just coming through. I can hear you clearly, but
all right.
You started.
I will try again.
Oh, yeah.
Yes, I will try again.
Oh, the suspense.
All right. Here I'll try to find the slides over here. Sorry for that.
Well, we know it worked just before. There we go. There's the first slide up.
Yes,
that's brilliant.
Thank you.
Okay.
All right. So thank you for the presentation for Jürgen and great presentation. Thank you all for coming in. So I'm developer at CSC, and we are providing national digital preservation services in Finland. And I will be talking kind of from higher level down to quite detail specific. So it's kind of going through for one corner of our preservation systems. And I've been talking more about the preservation ingest workflow and how we have been implementing the ingest workflows. So, but in short, so we have been providing national preservation services for almost 10 years now, and we have some 3 petabytes in storage, and it's yes, so we have been doing a long time and continuing development. So this is kind of the overall. And what we are really doing, we are cooperating with the organizations and our services. We have multiple different kind of organizations who are our customers and providing data to us. So our organizations are doing mainly the digitization and the archival stuff, and we are doing the preservation. So we are cooperating with the organizations and creating standards, maintaining standards, and providing some tooling for packaging the data, for extracting metadata, and this is our service what we are doing. And we are also providing the technical architecture, the technical solutions for bit preservation and migrations of the data. Okay. So, and we, as we know, the preservation starts at the organizations. We are mostly have been grouping this preservation topics to 3 different topics, like semantic preservation, logical preservation, bit level preservations. And mostly the content side, the organizations are mostly responsible of the semantic side and the content itself. And it's in the higher up here. And then we have this middle ground where we are thinking about file formats, standards, and these kind of things. And we are cooperating strongly with the organizations to figure out the best solutions for long-lasting solutions. And then the most important thing we are providing is the technical to bit level preservation at CSC. And it is going through all the organization levels, and it's a lot of cooperation with the organizations we have. And I think this is next. And the thing with our organization, we have 2 kind of organizations. We have the cultural heritage organizations, archives, who are already established organizations in the field, and they have ready and working digitization archival systems. They have services for the end users. So we are providing the preservation service, and it's kind of backup service for the archival organizations. And we are providing some tool libraries, the pre-ingest library especially, which is for helping the actual formalizing the metadata, formalizing the submission zip and the packages. And they are using mostly our REST APIs for transferring the data and receiving the data from our preservation service. So this is for us, this is kind of simple use case because they are already established organizations. Then we have the other kind organizations. We have the research organizations. It might be individual research groups or smaller groups. And on the science side, there's less knowledge and less background in the data management. So we have in Finland, we have this Fair Data Services, which provides easy to use unified experience for the research organization for managing the research data. So there is this research data storage IDA, which is for midterm storage for preserving the research data sets. They can be shared from there again. Then we have the metadata services, which mostly collect the not technical metadata, but descriptive metadata over there. And then what we have developing is this pre-ingest service, which kind of aggregates all the data sets and the metadata. And this pre-ingest service makes this formal zip-deep, the standardized zip-deep packages and sends them to our preservation service. So for cultural organizations, they are directly using the preservation service. And for research organizations, we have been providing these Fair Data Services that help the smaller researchers to maintain their data and also have digital preservation for their data. And we are using the same backend system, the preservation service. And I will be talking about the workflows here in the preservation service side, because there's quite a lot of things before the preservation, and I haven't been too much developing these things. So I will be talking more about those later on. But shortly, the pre-ingest in the either on the cultural organization side or in our pre-ingest service is mostly the same things. We are importing the objects, we are harvesting the technical metadata, then we are harvesting the descriptive metadata from other databases, creating the provenance information, like how it's been created, and these kind of so pretty standard things. And we have kind of different routes how these are generated. And the workflow in the pre-ingest service, it's quite straightforward. It takes the input data sets, databases, and aggregates them to a standard METS document. We are storing the metadata in METS documents, and we have standards there. We are using premise events inside the METS documents. And then we are adding some standard other metadata there, like digital signatures and some manifest files. And we are packaging them to single zip files that we are transferring to the preservation service then, and that will do that thing. So it's looking pretty similar in all our use cases, how it's going at. There are different implementations for these. But for the ingest workflow, we have been working on our ingest workflows, and mostly we have been using it for quality assurance. And for our preservation service, we have been requiring that all the data that comes in, it has to match fulfill our standards. So we have this workflow that is ensuring that the data is valid and it matches the METS metadata that is over there. And after this validation steps, we are going for the last steps and creating reporting over there. We're creating the ape files and storing them. And the workflow is automated, and pretty much the similar workflows are used everywhere. So we are using the same technologies, the same kind of workflows everywhere. And the same implementation has been helping us to implement quite fast, very different workflows when you have the technology for this. And some details of the ingest workflow. So before the real ingesting, we have preparing steps, the dispatch phase. So we are distributing the processing over our own computing cluster. And the dispatch phase is just selecting the validation server and chooses their worker process, which will process the zip and runs the ingest workflow, all the validation stamps and everything on one host. And it is dispatching them. Then we have this decompress because we have this zip or tar zip files. So we decompress them. And before any other processing, we are checking that if there are any virus or harmful code there. And if there's any detected virus or other complications, we just quarantine the code, or we quarantine the zip and it goes through further inspection later. So this is the preparation for the ingestion process. And then we have the validation steps. We check the signature that the author of the data is correct. We are using our, basically we are using manifest format, manifesting the METS XML, which is checksum, and we have the checksum signed with the S-MIME signature, which is good there. And with the METS file, we can ensure that every digital object in the zip file is valid and unchanged. Then we are maintaining a contract database for all our customers because we have many customers. We check that the organization has enough quota in our system and permissions to upload the dataset. So we are checking the authorization for them. And then we are checking the fixity of the objects that they have. There are no errors in the transfer phase. Standard checksums are used for the fixity check. Yeah, so this is the phase, and like the preliminary technical checks. Then we have more validation on the METS XML format. So we are checking that it complies our national profiles. We are using schema, XML schema for the METS file. We have additional schematron rules for the validations. And these are checking quite thoroughly the technical structure of the METS XML. We have little knowledge about the contents of the METS file, but for the technical side, we are quite strict that it adheres to our standards. And then we have the digital object validation in the ingest phase, and we ensure that every object is well formed, and also that the metadata in the METS XML and then the digital object, they have to match. And behind our own code, we are using pretty much standard tools like JHOP, Verapida, LibreOffice, and other things. Our own library is open sourced, the file scraper, which aggregates results from these tools and provides single JSON response. So we can call just scrape file and it returns JSON which tells that if it's well formed, what format there is. So this is useful library, I think, for quite many. And this is the more detailed analysis of the zip file. And then after we have checked the data, we are generating standard AIP format. This is we have been doing this for 10 years. It's since 10 years we developed this format. It's basic directory structure. We have been using the Bagit format. It's quite simple. There's manifest, the Bagit header file, and we are including every metadata, all the data from the zip package, and all the metadata we have been generating during the validation process. The ingest process, we are storing it within the AIP file. And it should be self-sufficient for the bit preservation. We can ensure the validity of the AIP by itself. We do have additional databases which contains checksums and things like this. But our AIP packages are self-sufficient for the bit preservation. And then we have the storing phase. So our storage part of the workflow, it's copying the AIP package to 3 different storage systems. We are using cluster_fs for our disk copy, and it's just storing it through the local POSIX mounts. And then we have 2 copies currently on IBM LTFS file system. And we are using remote storage servers on 2 different locations. So we are using our own REST API to transfer the data to the remote locations. And we have pretty similar workflow system also on the storage servers that's using storage-specific workflow for writing the AIPs directly on the tape media. That's about the workflow after storing. And after we have been storing the AIPs on the tape, we have 3 copies. We are storing the report to shared file system for quick access. And in the ingest report, we have the events from the ingest phase. And then we are delivering the ingest report to partner organizations or to our shared file system. And our partner organizations or the pre-ingest service for research data, it's basically polling our REST API to ask whether the ingest report is ready or not. So this is our way to check the data and how we have been organizing the workflow. Yes, this is the workflow. I go through quickly about some technical details of how this is implemented, about the software architecture, which is more of my field of expertise. So we have been using this Python Luigi library for about 10 years now. And it has been quite good in our use case because it's we get some standard structure for our workflow, our data pipelines, and we have been using the same tool for quite many different use cases. And there are some basic principles that have been helping with the error handling and how with the error handling of the workflows. So these are two things that are like atomic and idempotent workflows. So if we have some input data, the task we are running, it will always produce the same output. So we can run the same workflow as many times as we want, and we won't pick any duplicate results. And this has been very helpful in error cases like power failures or something else. We just run the workflow again, and it produces the same answer, the same result again. And this is the basic idea behind almost every workflow, every task we are writing, that every task must either succeed or then it fails. And when it succeeds, it writes output, it writes its final state. And from the final state, we know that the process has been successful. This is the principle behind the Luigi workflow. And with the Luigi system, it's good with the atomic sides and keeping things in organized like task dependencies. But then we have problem that it doesn't distribute the task over several servers. So we have been using the RQ, Python RQ library, which is WorkQ library. And basically, we have the zip coming through the web server to our shared network file system. And we have the dispatcher, which is pulling new data on the file system. And when we find any new data, it will enqueue the job, do the job queue, and we have our validation cluster. I think it's 12 servers currently, and there are multiple workers per server, so I don't remember how many there are. But then these validation servers with these worker processes, each worker process will run the whole workflow on one host. And this way we are able to utilize the local CPU memory and also the IO resources on the validation servers. Yeah, and we have been using both libraries, the RQ and Luigi, and these have been help us with quite minimal amount of our own code. We have been able to create these distributed pipelines for multiple different use cases. For example, we are using this for the same kind of architecture we are using for the pre-ingest workflows, for our ingest workflows, for data replication, when we are refreshing tape media from new generation tape media, we are using the same system over there. And what else to say about this? Well, we have our zip files, our zip files and AIPs are varying quite much in their size. So largest zip files are something around 1 terabyte or over 1 terabyte. And the smallest ones are something like 100 megabytes. And sometimes we need to process even 10,000 zip packages in one batch. So the scale and how our data looks, it's quite different. And with this system, we have been able to, it's been flexible enough to process all these different use cases. And more information about our systems, our standards, specifications are found on the internet, and that's pretty much it for me. All right.
Thanks very much, Mikko. That was
Thank you.
Very impressive and rich presentation there with lots of interesting workflows. And yeah, Jenny has already started the round of virtual applause. So if we can show our gratitude to Mikko. And in fact, we've got a couple of minutes just for some quick questions. And in fact, well, you've had some very positive comments in the chat about the impressive arrangements you've got in Finland. And it's a pity more countries don't have that kind of national service. But Jenny, did you want to follow up on your question in the chat?
Yeah, thanks. Thanks, Mikko. You talked a bit about the validation you do as part of your workflows. And I was wondering what happens when things fail validation, and if you've got sort of lead-on workflows or follow-on workflows that you go to in those situations to address any issues that arise.
Oh yes. So we have two kind of errors in the validation workflow. Either we have bug in the software, so our software crashes, something happens, and then the workflow only stops. And then we need to inspect it later what happened. And then we have these, we call it validation errors, when the file formats do not conform to the specification, or the metadata does not conform to the specifications. These we are calling validation errors. And for the validation errors, we are returning the report to the organization, back to the customer organizations. And then from the ingest report, they can read what the error was, and they can fix the error. And currently we are developing separate knowledge base in our GitHub, which collects different error messages and the solutions for how to solve these errors in the file formats.
That's great, thank you.
Thanks, Mikko. And the other question you had was from Christopher Werner, who asked, I guess when you're talking about your storage, he says, have you investigated or thought about using locks for storage distribution?
Yes, we were investigating logs 10 years ago. But currently, we went our custom solutions, and we are using pretty much quite trivial, quite simple storage systems. We are using directly ClusterFS, and it helps with our data management because things are files, and we can see the files. And then we have the tape systems, which are using LTFS, and we are also using pretty standard file systems there. And we have separate metadata catalog, metadata database, which is cataloging and keeping track the location of the data, where the data is stored, and on what file system, what data center. We are tracking these kind of things.
Okay, thank you. And I see Heikki wants to come in.
Yeah, I would like to continue about the logs, because some of our customers in Finland, there's a legislation that they have to store the data inside Finland. So logs doesn't fit in that picture.
Okay, fair enough. Okay, well, if there's any more specific questions about either of our first two speakers, perhaps you might want to post them in the chat, or otherwise, I think we should move swiftly